All right, good evening, everybody. Can everyone hear me okay? I think you can enter, say yes or no in the chat window, I guess. So, going to assume everybody can hear me okay. We'll just give a minute here for people to join, then we'll get started. Okay, great. Looks like everyone can hear me. Thanks. All right, terrific. So thanks for joining us tonight. Appreciate everyone taking the time out to come and join the session, hear what we have to say, and hopefully be introduced to our products, and you'll find them something that you find beneficial to explore more. So without further ado, this is going to be an introduction to Mono for Android and MonoTouch. There's no prerequisite as far as knowing either platform or product. I'm not going to go into anything too deep. But a little bit of background in Android or iOS, or at least some familiarity with those platforms wouldn't hurt. But this is going to be pretty much a pretty high-level talk. We will get into some examples, and we will show some details and some code. There'll be some hello world, as well as a couple more, a little more involved examples as well. So I'm Mike Bluestein. I work for Xamarin. I'm a technical writer on the Xamarin documentation team, and there's my email. It's mike.bluestein@xamarin.com. So if you need anything, or you have any further questions after this talk, like some more information, whatever, just want to say hello. You're welcome to feel free to email me at that email there. So let's move along then, and we've got a lot of material. So let's get started. Again, like I said, it's going to be an introduction to Mono for Android and MonoTouch. We're going to start with Mono for Android, work through that product, and then we'll transition into MonoTouch, and we'll show you that as well, and then we'll show you where cross-platform can come into play between the two products. So we're going to talk about how each product works, what's supported on each platform, what features of both the native platforms, either Android or iOS, are supported, as well as what you get with C# and .NET available on each platform. So there's a little bit of difference there. We'll show the tooling support, both MonoDevelop we're going to work on the Mac today, and we're going to show everything in MonoDevelop. But just note, Mono for Android is also available on Windows, and it's available on Windows in either Visual Studio or with MonoDevelop as well, if you don't have Visual Studio. And we'll talk a little bit about that. MonoTouch, however, because it's it's an iOS product, you have to have a Mac to develop for that. So we'll go into what's required a little bit more throughout the talk. And then we'll have a few application demos, and we'll try. I have a lot of slides, but I'll try to spend more time in the code, or at least try not to spend all the time in slides, and at least have a nice balance. So let's get started. What's Mono for Android then? So it's a platform that allows you to develop for Android, native applications in Android using C#. So the Android SDK is available with Mono for Android, and we expose it through something we call bindings that are available in a DLL that ships with Mono for Android called the assembly is called mono.android.dll. So what Mono for Android enables is it enables code reuse to other .NET environments, such as iOS through MonoTouch, which we're going to talk about, or other environments like Windows Phone, or even non-mobile platforms, for that matter, places you may have existing code bases. So we'll talk a little bit about code reuse towards the end of the talk, which it'll make more sense after seeing both platforms in action a bit. So Mono for Android is supported on two different platforms. It's supported on OS X, as I mentioned in the introductory notes, using MonoDevelop as the IDE. Or if you develop on Windows, you could use Visual Studio. You have to have 2010 Pro or above, or Ultimate, one of those versions. It isn't supported in the free version of Visual Studio. However, because it's a plugin, so that add-ins aren't available there from Microsoft. But MonoDevelop is available on Windows as well. So if you're on Windows and you don't have a professional version of Visual Studio, you can use the same MonoDevelop IDE that works on the Mac, you can use on Windows, so either environment. To get started, you need to get a variety of things when you're installing Android. And then to use Mono for Android, there are a few things you need over and above that. So there's the Java SDK, Android, and then a variety, all the things that you would need for Mono and MonoDevelop, the Mono for Android SDK, the GTK Sharp for the tooling, and things like that. So to make that easier, instead of having to go through and manually install all of these things, we have an installer you can get. So if you go to the website and you sign up and you download the even evaluation version or you buy it, you just get this installer, and once you've activated, you could just basically click through a wizard and install it. And that's available both in Mac or on Windows as well. So it makes it pretty seamless. So before we jump into explaining all the details of Mono for Android, I wanted to go through this just simple example. You know, it's not exciting, it's a hello world, but I'm not going to go through too much, but I'm going to spend some time in the code and show you what you get out of a hello world application, more to look at the project template, and we'll talk a little bit about how Mono for Android works after seeing the simple app. So let's just jump over this code now, and I got that already open back in here. So I've already gone ahead and I pre-created this for time's sake, since we only have an hour here. You have a lot of material to cover through two projects, or two platforms rather. I already pre-created it, but so this is a product you get from the Mono for Android, creating a new Mono for Android application in MonoDevelop on the Mac in this case, and it's the same. You know, using MonoDevelop, it's very Visual Studio-like, so you know, it should be pretty familiar to folks, even if you've never seen it. A lot of the features are very similar to Visual Studio, but again, fully, you know, same projects even will fully work. I could put this right over to Windows and just open it right up, same solution, same project format, whole thing. So that's pretty cool. So over here in the Solution Explorer, Solution tab, we call it in Mono for Android, you'll see there's this file that gets created called Activity1. Now, I'm assuming if you're already done Android development, maybe in Java or even with Mono, you already know what Activity is. But we're not going to make that assumption here. So Activity is it's a class that allows you to, for the most part, put screens up to show users. It doesn't have to be about screens, but 99% of the time it's related to a screen. So what this class here is, Activity1 is just a subclass of Activity. And in Activity, it's kind of like a page. Android's the design in a lot of ways is a lot like the web, or a lot like things like ASP.NET, maybe even web forms, things like that, where you had a page lifecycle, or other things where you'd have a pipeline. There's lifecycle. Even though it's a client-side stack, you know, Android goes on a phone or on a tablet, and you know, other environments. It's you know, mobile devices, but it still has this sort of design that is a little atypical. So you create these activities. You can almost think of them like pages, and then they have a life cycle, and then there are methods you override during the life cycle to do stuff. Right? So we'll come back into there in a second, and we'll look at the code. But first, just let me run the app, and I'll show you it running. So I'd already started the emulator because emulator takes a little bit of time to get started. This happens to be a x86 emulator, which I have some slides later when we go back that I'll show you the benefits of that. The big benefit is it's fast. The other benefit is you can get GPU emulation, so that's cool too. So you can do, there's a few things you can do in that. So we're going to talk about that a little bit more. But anyways, I already have it open, and I just launched the application from MonoDevelop by clicking the Run button up on top, and I just get this simple app with a button, and I click it, and I get pull up from the button. Okay, nothing too big there. Well, let's jump back over to the code now, and it's more interesting to show you what's going on. So this first block of code is created in an onCreate method. So that's one of the activity lifecycle methods that there are. There's a variety. There's a whole lifecycle again that the activity goes through. When it starts up, when it goes into the background, things like that. When it restores, when you put state back in place, and when you restore state, kind of very similar to if you maybe doing web development where the web's stateless. Here you can maintain state because it's a client, but there are a lot of similarities in how they designed it. So in this case, you have to override this method called onCreate. And that happens when the activity is created. And in there, I can do work to create my view hierarchy. Once I create my view hierarchy, I can then add my view hierarchy to the screen. And then I can run code like you saw with a button and an event handler and a label. The first part of this code here, I have another example down below where I'm going to show you a different way to do it, is where I do everything completely in code. I create this thing called a linear layout. So in Android, there are a variety of layout controls. If people are maybe familiar with things like WPF or Silverlight, stuff like that, even HTML for that matter, there's because of the layout, right, and the controls that do layout. So this one here is called a linear layout, and it's a lot like say a stack panel if you're familiar with Silverlight or XAML, that kind of stuff. So what it does is it creates all the controls you put into this linear layout will just get stacked either horizontally or vertically. In this case, I set the orientation to vertical. And then I create some controls and add those controls to the layout at the end. The first control I create is a thing called the text view. I called it a label. It's basically like a label. And then I call this method set text, and that basically sets. It's a Fluent type API, so it's like setting up the text property. But in order to be able to do that kind of API and chain things together, like they do on the Java side. We have it as a method here, set text in C#. And I'll come back to this resource business in a minute, and I'll show you what that is. Then I create a button after I create the text view, which is my label. Same thing, I just set the string that goes on the button. And again, I'll come back to the resource in a moment. Then I can create an event handler for the click event, and I'm creating a .NET event handler here for what's actually, this is where our bindings come into place. We expose the Java listener interfaces as event handlers in C#. So you can create an event handler for controls and classes in C#, just like the whole thing was developed in C#, even though these controls originally come from the Java side of things, right? And through our bindings. So that's all kind of hidden from you. And then I could either put an anonymous function, an event handling method, or just give it a lambda like I did here. All of that's available. And in there, I can then set the text property. In this manner, I can do it through a property as well, just to show you the differences there. So here, I'm then just setting the text through the also exposed property on the binding. And I just set to the simple hard-coded string of hello from the button. And we add the two controls to the layout, and then we call this set content view, which is a method that comes from the activity, to actually put the layout on the screen. And then that's how we get our UI that we just saw. Then we have to run it again with the button and the label and the text view, excuse me. And clicking the button handles the code in here on line 31, and it changes the text. Pretty simple. So all available, as you can see, all available in C#. These classes, like this thing like text view and button, I'll mouse over for a second. You see it's an Android widget button. So that's our binding, that mono.android.dll. So we bind all the Java APIs that are in the Android SDK. And we have capability to allow you to bind third-party things as well. So if there's Java libraries that come out outside of Google, outside of Android, you're more than able to use the exact same binding technology that we use internally to bind all of the Android SDK itself. And I have some slides at the end that'll show you how to do that, or at least mention it. It's very simple through some project support we have in the tooling. All right, so that is doing it completely in code. Now let's just hide this. And the one good time to use regions is when you're giving a talk like this. You can hide stuff. All right, so excuse me. So again, I have this set content view just like I did up above, but this time instead of giving it a layout that I create in code, I'm giving it this thing called a resource.main.layout. So this is a good time to talk about resources because we had them up in the example above where I'd set the two strings to resources, this resource string hello label text and same for the button text, and now we see it here with this resource layout main. What that is there's this folder here called resources, and you see there's a bunch of subfolders underneath, values, layout, drawable. So all the stuff you create in these files, be they string resources, like let's just open up the strings.xml, that's where those two strings come from. Well, it's just how the Android does resources. They do it through these XML files they have here that you store in this sort of special folders, right? And they have a build action that does something I'm going to show you in a second. Likewise, there's other kinds of resources like layouts, which is where this main AXML comes from. I'm going to not open it for a moment, as well as drawables and other things like that that have images, stuff like that. So anything you set in or add to any of these sort of special resource subfolders, it gets generated into this file here called resourcedesigner.cs. And this is similar in Android. There's like this R class, and in C# we have this class called resource designer. So anything you've added in here gets identified in these classes that are. You don't have to do anything in this class. It's a generated class. You can change it. But this is sort of a references to all the things that you add declaratively in the various XML files. So there is where I have the button, and that's how we reference it, and the label, that's how we reference it. Same with the layout, which I'm going to show you, and main, what that is in a second, and that's how we reference that. So yeah, so that's how we reference resources, and then you just do it through the class. So resource ID, a button, resource ID, a label here. Same thing for string resources. We had a drawable, which is basically something that you draw like an image. Same idea, you'd have some resources drawable thing that you'd reference. And then they're used in various places. Up above in the first part of the example, we saw how it was used in to create a string resource. Here, we're doing this find view by ID using a generic method, but giving it a button or a template. There's an advantage over Java in our bindings by having the C# language. We have it exposed to generics there. And so you wouldn't have to, it saves you having to do a cast, it becomes strongly typed. So that's good. And then we give it this resource ID button. And where, though, are these things coming from? They're coming from, in the first part of the example, I did it all in code, but in this part, I did it in this declarative fashion through this XML file. There's a linear layout with a text view and a button. And by giving these text view button, things like that, this special syntax that this markup kind of syntax they have in the XML for Android, @ plus ID. That's what causes the ID to get put into the resource file. Same thing down here with the button, and then here's how I reference. This is the opposite, referencing those same string resources from the XML like we did in code. You just use this @ syntax here. So you might have noticed I clicked a little quickly there. We have recently in the latest version of Mono for Android, we came out with this designer support. So simple app here. What this designer does is, I'll just show you here over on the right. We can come over there in the toolbox and we can search. Say I can search for an image view, and there are a variety of all the different kind of widgets you'd ever want to add. And we can drag, and there's a bunch of support for where you'd want to insert it. You can see it changes from green to blue. It shows you the insertion point, gives you a little tooltip of what you're dragging. When I drop it, it gives me a little preview placeholder. The blue border shows you what's currently selected, and then it changes the properties down in the lower right-hand corner. And what this does is this is a designer on top of that XML format there. So anything I would change in the designer would just get changed in the XML. And I can do things like I can double-click on here, and I can change the button either to a resource to select, or I can change it to a hard-coded string. Likewise, I can select on one of these controls widgets and come down to the property grid and set stuff. For example, excuse me, I can come down here to where it says the source for the image view I just dragged and click on this little magnifying glass, and I get a resource selector. And this default, the default product just puts in this one drawable, which is just the icon. If I select it, it sets, it's per context. So here I'm selecting the source of the drawable. It knows to just show images, and I can select that image and go OK, and then it draws it and gives me a little preview. Then I could run the thing and it'll, let's just run it. And it'll appear. It'll rebuild everything, repackage it, redeploy it to the emulator. Everything works well. Give it a second. So the assembly is pretty quick. So if you use, traditionally the emulators have been ARM, they emulate ARM in Android. We'll talk about it a little bit later. That's what most devices are, but this having an x86 emulator basically makes it a lot faster. So that's a big benefit. And yeah, you can see the image there. So just show you a couple more things in the designer, then we'll move back to the slides and talk a little bit more about what went on under the covers. But they're stacked. As you can see, I got that automatically because I'm in let me show the document outline here. And I have a linear layout. And I can see that I have the hello, the label, the text view, the button, and the image view I dragged. You see these two arrows. You can change for things that actually can have their layout properties changed. You can hit these little arrows to make them size differently according to Android's XML schema and attributes, or I can size them absolute fashion. And when I do all that, all it's really doing under the covers. I'll just reload from this. Hopefully that some kind of thing. It just changes the values in the XML and it keeps it all in sync. So that's how I'll just say that there. That's how you work with a simple application in Mono for Android. We're going to come back in a second, and I'm going to show you a little more involved example. Let's just quickly jump back over to the slides now. Right here. So it's a quick page, just give you the development experience. It's pretty seamless, and it's exactly the same thing if you were doing it in Visual Studio. Same designer support, same everything, just you're in Visual Studio. So how does all that work? So we saw, we talked about the resource designer file. It's generated for Android resources, things like drawable strings. If you change layouts like to or to be in portrait or landscape, you add other resources for a particular locality, language, things like that. It has complete support for that. So that's where you can do it declaratively, or you can access things in code through resources both ways. So like as we saw with the @string thing, so in images, strings, etc., things like that. And when all of this is when you're done, and I had built it and deployed it, everything was compiled to a .NET assembly, right? But so there's a bunch of managed code. So that was a trivial example. We didn't show much there. But if you have like classes or things you brought over that you may already have an existing code base, things that do non-Android things, XML, parsing, JSON, whatever it may be, that kind of stuff will just get compiled to .NET assembly, just like normal, right? Like you always would using Mono, right? But there's also, how does the Java part work? Well, we have these things called Android callable wrappers, and the Android callable wrappers are what I mentioned before. That exposes anything from .NET has to be consumed. There's Java, and there's all the Android classes, and there's all the events and things that are raised on the Java side of things, right? So the Android callable wrappers are generated when the package is created, and these Android callable wrappers are what basically allow the bridge between the two worlds, between the the Java world to the C#.NET world. And you don't have, if you're just using everything from Android, you don't have to, it's all done for you automatically. Excuse me. You don't have to really be concerned with it. It really only comes into play where you have to start thinking about how do you work with Android when you're going to start binding like a third-party library, something like that. But that said, you have pretty seamless tooling that makes that really easy to do now. So we'll talk a little bit about it later. So we saw the UI designer briefly, and you see here, this is a screenshot on the left-hand side. You can see the exact same thing is available in Visual Studio, as I mentioned, and like as we just saw in MonoTouch. So the UI designer has a lot of support other than just being available in both environments. It allows you to visually construct these view hierarchies. We saw how you can lay things out quickly. You can select resources, be they strings or images, things like that, and you could add a variety of widgets to the screen and build up your view hierarchy. And then it keeps everything in sync in XML, and you can see your document outline. Great resource support. But then there's other things. Support for Android themes. Things like where you go from one style to another. Different devices have different themes available. So we'll just I'll just show you what that is in a second. I'll jump back over to the IDE. And there's also support for great support for resources and device profiles, conflict resolution for when you do things like, say you're designing a screen for portrait orientation like we had there, and then you're going to switch and you want to design the screen a little bit differently when maybe the user rotates the device when they go into landscape. And maybe you might add different controls in one orientation. We're calling that a profile in one orientation or another. So maybe code would run when you're in one orientation, but then the controls aren't there in the other. So you wouldn't want to have it there, and you have conflicts if those kind of things happen. So there's great visual support in using the designer to resolve these kind of conflicts, and it's really really intuitive. We have a document. I'm not going to go into it in detail here. We don't really have enough time to do that, but we have a really great document that goes through a detailed overview of the designer on our doc site. I'll reference that at the end, the site at the end of the talk, as well as we have a walkthrough tutorial as well up there. So you should check those out if you're more interested, a little more detail. All right. So yeah, and then conflict resolution. So I mentioned the Android SDK. I mentioned how when the thing gets built, Android callable wrappers are created and packaged up in the packages deployed to the device or emulator. So you might be wondering, well, what's available in the Android SDK? So all the technologies. In Android, I mentioned activities briefly. You basically get everything from Android as of the latest version of Mono for Android. So all the kind of things you can do in Java, you can do in Mono for Android via C#, right? Because we bind the whole thing and all the technologies. So intents, activities, services, content providers, the newer support in the ICS and Honeycomb, they came up with these things called fragments. Those are their later, the tablet version was called Honeycomb, and then the later Ice Cream Sandwich is ICS. That's their latest version of Android. So we have full support for all that and fragments, as well as there's some backwards compatibility libraries that let you use fragments on older devices, because there's a lot of different devices and a lot of different what are called API levels, and some things are available in some places, some things are available and not available. That's just Android. So fragments came out later, right? Came out as of the last few releases of Android, but they're still, the majority of Android devices didn't have, those later releases of Android. They were either 2.3.3 of Android or before. So Google made a compatibility library, a support library, they call it, and we have full support for that as well. So you can do, et cetera, et cetera. Anything you can do in Java, you can do through the latest version of Mono for Android. And then if there's third-party things and someone writes some Java, do it again, that's all available. So here I just want to, we're gonna also get into MonoTouch here in a second, but I just want to go in now into this example here. So it's still kind of a simple example, but a little more involved than Hello World. And the reason I'm going to show it to you is because we're gonna do when we get to MonoTouch in the second half of the talk, I'm going to have a similar example, and I'm going to show a little bit of code reuse of what we mean when we say you could reuse the non-UI portion of the code. So what this example is going to do is just going to put up this list here where it's just going to call it's called the Bing. I just hard-coded in a search to Bing. I think I passed in the string Xamarin in this example here. And I just put the results back in a list view, it's called. And on the right, and when the user selects any of the rows in the list, they'll just get taken over to a browser screen where it loads up the page that goes with it. So let's jump ahead. Let's jump out of here rather. Go back and let's see how that works. So, slide this out of here. Excuse me, give me a second here. Just okay. Sorry about that. So here again we have activities. The same idea. Let's just get all the files open so you can see what's going on. So yeah, let's run this and I'll show you what it does before we go into the code. All right, so here I just ran it. You saw it deployed really fast into the search. That's the x86 emulator in action, how fast it is. So, and this one's running a level 10, so that would be a level 10 emulator. It means it's basically, most Android devices are running that now. That's Android 2.3.3. They also, Google recently, like last week or two, just came out with support for the newer ice cream sandwich emulator, level 15, and we have support for that as well. I mean, so we pretty much support everything right away. You know, as close to right away, you know, within the next day on both Android and MonoTouch, which we'll get into later. So this we keep up with these things going forward, and that's been the case historically. And it's a function of how we've designed everything that we're able to keep up so well. One part of it anyway. So here I searched for it, and I got this list, and just I did a search for Xamarin, and like I showed you in there, I select that, and it just goes, and I can using the Bing web service there, right? So I'm consuming the Bing web service, and then when I select it, I go over and I load up a page with Xamarin in it. Web page in it. So I get my ID hidden here. So you would need to get a Bing ID API ID from Microsoft to run the example. They're free, for development. It's free for a pretty good amount of calls. It's fine for development, and then they start charging you after. So that's available on their Bing developer pages. So anyways, though, here I just got a query, and this code here, this is kind of why I wanted to just make it a little bit bigger. This code here is the kind of code that you could reuse. So you'll see it, other than changing some variable names in the MonoTouch example we're going to run, there's a couple other things in it. But I'm just using, .NET classes, HTTP web request, simple in this case. And I'm giving it a URI, and I'm just calling it asynchronously. And then in here, I'm just just normal .NET code. I'm getting back. In this case, I'm touching the Bing's JSON API. That's why I like that they have JSON support. They have, if I wanted to do an example for web services, they have XML. So they have a variety of different flavors of their web service. So it's kind of why I use it. And you can see down here, I just get response stream. We have typical system.json, get a JSON object, and then I just use link to parse that JSON and then load it up. So all this code here doesn't look Android specific because it isn't. So that's the kind of code that could be reused. Now, it's a simple example here, but still, I mean, you can imagine, if you were making some kind of a search app or you had a lot of API features, some kind of mashup kind of app, that could get involved. It could be quite a bit of code there. And if you were to build it with the native tools, the native SDKs, such as Android or iOS's stack directly, you would not be able to reuse that code, right? Just because Java is not going to be available in iOS, and Objective-C is not going to be available in Android. However, by using Mono for Android, you're able to take both your skills and the C# language and the benefits that come with that, pretty modern language with a lot of good features, things like link and lambda, stuff like that. But additionally, you get the code reuse and skill reuse. You get this code reuse. So things like web services. Either all different flavors of web services, be them if you have an old web service, something in your business that maybe was developed with SOAP, or we have a little bit, we have partial support for WCF, so we have some things like basic HTTP binding. We don't have a full WCF stack, but a full HTTP stack and a variety of different ways to do JSON and XML parsing and link and all those kind of things, and that can all be reused, right? And we'll do that here. Now, at the same time, you don't have to give up anything because you still get the native stack. So you still get all the native controls from Android. When we do the iOS one, you get all of UIKit and all the foundation classes that come from Apple as well. But the same story, where you'd be able to reuse all this kind of code. That's the kind of code that security code, parsing, web services, storage, any algorithm, anything you would write that isn't UI code. Now that said, there are some UI things that are device specific, things that use sensors like the accelerometer location GPS. I'm going to just remember that I'm going to talk about that at the end. We're working on something to even allow you to abstracts that a little bit. And even so you'll even be able to you'll be able to get code reuse even in that case through some helper libraries that we're putting together, and they're in free release right now. And I'll mention those. I have a slide of them towards the end of the talk. But then down in here, this is the kind of code now that I'm going to now start touching an Android-specific thing called the list adapter. And this is just their pattern. They have this thing called a list adapter, which is an adapter that allows you to get from data to a view. And a list adapter is a special kind of adapter that has its view be a list view. So that's how I get the list of things. And I'm going to hook it up to this array adapter. And again, I'm going to take advantage of C# and just use the generic to give it this search result item. That's my model in this case, right? And I'm just going to put the details in there of the results I got back and what view I'm going to use for each particular item, which is just the particular row. In this case, I just put a string, right? And the search result item, again, now that's the model. Again, just a title and a URL. I needed the title to show it in the particular list, which in the Android, I'm doing one little Android trick here. It's like for a list adapter, since it only supports showing up a string like that, so you can override string on your model, and that's how you can show it. But there are more. You can make more complex cells by creating your own custom adapters, and there's a bunch of stock cell styles, so you're not limited to a string list. But for example, I just did it with a string. But this model code, obviously just two properties, trivial here, but the title and then the URL you go to, any validation or anything like that, a more complex model, you'd be able to reuse that as well. So, and we will, as I tweak some names when we go to the MonoTouch example in a moment. And then down here, I just have some Android-specific code that's an override of on list item click. That's how you that's how you, in an activity you can handle the item click. There's also an event. I'm doing it more the Android way here. We could also expose it to an event as well. And I use something called an intent. I'll just mention what an intent is. We can't go into it too much detail there, but we talked about activity a little, how it's kind of like a page in a way. And intent's really just like a little message, like almost a little asynchronous message. And you're just announcing your intent to the system to do something. And you can, I have an explicit intent where I have this particular activity in my class of a certain type, and my intent is to open up and show a screen for that activity. Or I could have an implicit intent to say do things that are, hey, Android system, I want to dial the phone, I want the phone dialer, I want to open a map, things like that. So in this case, I'm just using, I'm doing it implicitly, and I'm taking advantage of Android having a browser, and it just uses that there's a URL, and I want to view this URL, and then it implicitly opens up the browser app. The browser application. I could just as easily create an activity, put a browser controller, make it real custom if I wanted, and then do the intent that way. And then calling start activity starts it. Then I just have this little pop-up if something went wrong, if there was no URL on the result. That's what a toast is, just a little slide and pop-up at the bottom on Android. And that's it. And then all the stuff up in here, this layout and other business drawable, even just like in the hello world activity. And you can do things in code, or you can do them in completely declaratively, and the designer support is fully there. So that's our tour of some examples in Mono for Android. Let's get out of that and jump back over to slides now. All right, so some other things that are available. So that's all we're going to do for examples on Mono for Android, because I want to have some time to do the MonoTouch side of things. But I mentioned Java library. So Mono for Android, again, it ships with the full bindings for the Android SDK, right, through that deal, the Mono Android DLL. Now, there are a lot of people developing third-party libraries that they can be used as well. And what we have in a latest version of Mono for Android is a thing called the Java Binding Library Project. Again, very well documented up on our doc site at docs.xamarin.com. There's a walkthrough, and there's a more detailed document as well. But it's just basically a project, as you can see here, either in Visual Studio or in MonoDevelop when you're using Mono for Android. And you create a Java bindings library project. You would point it to the jar file, which is basically a library, an archive, Java archive that has all the Java code in it. And then from that, you create a binding on your own automatically to be able to then add into a Mono for Android project and then consume it as if it was just more managed code, right? So and then I've already talked about this. There's this x86 emulator support. So the ARM emulators have been there historically. Just recently, in like the last month or so, they came out with Google came out with API level 10, which is Android 2.3.3 x86 emulator support, and now they have the ICS one, API level 15. It's faster, much faster, as you saw. If we did that with ARM, it would have just been slower to launch, slower to deploy, just slower in the emulator. Now it's real fast on the device ARM and good on battery. That's why people use ARM. But on a desktop, if you're not using a simulator, right, which is what Apple does, and we're going to see in a second, if you're using an emulator and emulating the architecture, emulating ARM is very slow on a desktop, right, through an emulator. So that's why the x86 emulator is really, really beneficial. That said, you still, of course, want to have a device, and the experience deploying to a device and debugging and full debugger support, everything is all supported and all there, and very fast. It's actually faster than any of the emulators, even the x86 one. And the other thing I want to mention is also hardware accelerated GPU support in the new emulators they have. So you can do certain things that you couldn't do without. There's certain classes that require hardware acceleration. Specifically, there's some things in the latest version of Android. That's where they did a lot of work with their whole rendering pipeline, making it hardware accelerated. There's some classes called texture view, things like that, as well as some camera support, some stuff you can do now in the emulator that you don't need a device. It makes it real convenient, right? So that's our whirlwind tour of Mono for Android. Now, let's jump over to MonoTouch. So I talked about Mono for Android and how it abstracts the native platform and allows you to then use your C# skills, use tooling that looks real familiar, or completely familiar since you're using Visual Studio, optionally if you want to in that case, and use all of bring all of .NET over and C#, and at the same time you can use all the native stuff. So MonoTouch is similar in that it's a platform for creating, again, it's native, it's the same story. You build a native application, you use native controls, Apple's controls in this case, just like the Android one is Google's controls for the UI. So it's not a UI that's out of place, either in look and feel or capability of what you can do, or in performance. It's the same as if you did it with the stuff directly from Apple, because it builds on top of it. But at the same time, you get that code reuse story of the C# of your C# code. So same kind of idea here with MonoTouch is that you have a native tool chain, right? And we build on top of Apple's tool chain, and we're going to see that in an example. It supports, of course, everyone knows the App Store. It fully supports the App Store, and there's thousands of MonoTouch apps. Some very good ones, some that have been featured by Apple, some that have been put in the Apple stores worldwide on their sample devices. I mean, some really, really great applications people in the community have built. So at this point, it's getting very mature. It's MonoTouch. I'll just a little history. MonoTouch came first, and then the Mono for Android product followed. And now the Mono for Android is now getting very stable. It's always been stable. It's getting very mature and full featured, especially with the latest couple of releases. So MonoTouch is quite mature. It's been around now for a few years, over a couple of years now, and it supports all the deployment scenarios you want: App Store, enterprise, for like big shops that have in-house deployment, obviously development. Deployment and ad hoc deployment for beta testers, things like that. So here's a big difference though with MonoTouch versus Mono for Android. So since Mono for Android is all built in Java and they JIT2, right? So Mono for Android, you don't have this one limitation that you have in MonoTouch. In MonoTouch, there's an ahead of time compiler. So mostly probably .NET developers listening, I'd assume. So obviously .NET is IL, and the IL gets JITted, right? So you can't JIT on iOS. And the reason for that is you can't execute writable memory, right? So you could JIT, you couldn't execute it, right? So it'd be worthless. So you can't do certain things. We'll mention those things in a bit. But so with MonoTouch, there's an ahead of time compiler, like a C compiler, right? So that basically goes straight to the native architecture. So you go straight from IL to that. There's no JIT that takes place. So like Android, Mono for Android, though, there are bindings to these Objective-C classes. So there's a ton of thousands and thousands, tens of thousands of classes from Apple, and those are fully available in MonoTouch. Again, through bindings. Oops. Excuse me, my headphones. Sorry, cut a wire in my headphones. Sorry about that. All of Apple's iOS SDK is available, and everything they have UIKit, all their abstract, their kind of higher level higher level part of their SDK is UIKit, sort of their UI framework, things like that, or as well as down to their lower level C libraries, things like core graphics, core animation, some other stuff like that. Core image, you name it, everything, even OpenGL. Now I'll make a note on OpenGL. So OpenGL is exposed in Mono for Android and MonoTouch through a project called OpenTK. It's a low-level C# binding on top of OpenGL. Now that whole story of code reuse of the non-UI code, if you're developing a graphical application, say a game or some kind of drawing application, thing like that, something heavy on graphics and using OpenGL via OpenTK, at that point, now you can reuse all your code almost. So there's people that have gotten nearly 98%, a little more code reuse, very minor. It's because even their UI is built on top of something that's reusable. So for that kind of application, you'll get the whole thing because there is no, it's native, but you're not using native controls. But for applications that are going to use the various native UI frameworks, you'll pretty much, hard to say the amount of code works, but code reuse, it would depend on the application. But you, for the most part, be able to reuse almost all of your non-UI code, with certain exceptions. Depends on what you're doing, but you get quite a bit of code reuse even in the toughest scenario, right, where you're doing completely native UI. But in these graphical applications, things that we use OpenGL, you'll get a lot if you're building an app like that. So that's kind of cool. So, and then we have bindings, like I mentioned, to all of Apple's stuff. So along with that, you get garbage collection. So the memory management model in iOS, much like they don't allow JIT, they also have a memory management model that is very different. Not very different. It's different than .NET as well. There's no garbage collection with Objective-C on iOS, right? On iOS, they do have it, but they're kind of moving away from it even on the Mac too. They have made it a little nicer in more recent, the latest versions of iOS, where they kind of abstract away their memory management a little bit, but it's not garbage collection. It's a thing called they have a thing called ARC now, but they use things called retain count. So it's a lot like COM and COM reference counting if you're familiar with that. So, but go with MonoTouch. You get garbage collection in all your managed classes and all the classes that are bound to Objective-C. That's all abstracted away in the bindings. Likewise, you get the MonoDevelop IDE. That's the tool you would use to develop code with MonoTouch. So Visual Studio, there are people that have made some projects that allow you to actually write MonoTouch code in Visual Studio. But because iOS development requires a Mac for their tool chain, for their code signing and deployment, you have to have a Mac. It's a physical, limitation from Apple. Even if people are using Visual Studio through a way that is unsupported by Xamarin, some third-party way, and people are interested, I can get them a link to some projects that allow them to do at least code editing and at least work on the reusable side of things in Visual Studio if they like that. They want to use tools like Resharp or things like that. You'd still need a Mac to build and deploy. So, but there's MonoDevelop's the IDE that we ship, and it again it's the same thing that we saw in Android. Is full support, debuggers, excellent debugger. Both to the iOS simulator. It is a simulator as opposed to Android. It's not an emulator, so we can talk a little bit about the differences there. And there's a profiler as well we now have that allows you to profile performance and memory. And we also have unit testing support. So in MonoDevelop always had unit testing support. But now this unit testing supports this thing called Touch Unit that we have. It allows you to do unit testing to the device. So if you were touching classes that are bound to iOS, or you need iOS to run this kind of test, you can use this unit, this MonoTouch specific unit testing support to actually run those kind of tests as well, either unit test and/or integration tests. And that all works inside of continuous integration tools that probably from things like Jenkins and TeamCity, stuff like that. So there's many apps that have been deployed commercially. We have on our site, if you look at in the App Store, that is, if you looked at our showcase through Xamarin.com, you can see Xamarin.com/apps. You can see all these different applications that people have deployed. I got a screenshot there of one that I think is really kind of great. It's a thing called it's a flight simulator. So there's one that's actually built on top of a project called Mono Game, which is an open source implementation of XNA that builds on top of that OpenTK stuff that I mentioned, that does OpenGL. So, and these guys, what they did is they actually used that, and then they built that originally had only 2D support, and they built 3D support into it and then gave it back to the community. So that was pretty great. So this Infinite Flight, that's a cool app, and there's a bunch of other ones there. There's thousands, and like I mentioned, even Apple's featured some of them. So it's kind of a testament to how much good work everyone in the community is doing. So what do you need? You need a Mac, like I mentioned. You'll need an iOS developer account. So to do simulator-only development, you can get that for free. Likewise, you can get a simulator-only evaluation version of MonoTouch to try it out. But to put things on a device, you need a paid developer account from Apple, and you need a license of MonoTouch. And there are various flavors of license. I won't go into that, but you can see it up on our store if you're interested. And you need Xcode. So MonoTouch builds on top of Apple's toolchain. And so you need to get the developer account, install Xcode. With that, there's one installer that Apple has, and we have a doc that points you where to get everything and how to walk through it. You need to get Xcode, you need to get iOS SDK. If you're putting things on a device, you need to set up a thing called a provisioning profile. So it's all pretty well explained on our doc site. And once you get everything set up, then it's it's pretty seamless. It's basically just push button and deploy either to the simulator or to a device, either iPad, iPod Touch, or an iPhone, of course, right? And you need all the Mono Develop, MonoTouch comes with their installer as well. So a little bit about what's supported. So again, native APIs, anything you can do in Objective-C, you can do in MonoTouch, right? Across the board. And C and Objective-C is a superset of C. So there's a variety of things they have that they do in C. And you can do all that as well. And of course, all the OpenGL stuff I mentioned. Additionally, though, the opposite isn't true. Anything you can do in Objective-C, you can't do in the Objective-C developers are kind of a little more limited, right? Because they can't do the kind of things MonoTouch can do, because MonoTouch brings in the .NET base class libraries. So there's a few things I show in the screenshot on the right. So all that kind of stuff. So that's where you get all the code reviews, things like LangChain and things like XML parsing, JSON, web services, and you name it. So what's supported? Lang, like I mentioned, generics, strong typing. That's important because I won't go into the Objective-C language a lot, but by using MonoTouch, it actually strong. There's a lot of when you go against the Apple's iOS SDK, there's a lot of things that are either through constants or strings. It's a little, it's not dynamic, but it's a little more dynamic, right? So everything through our bindings, we can make certain things strongly typed. So you're not putting a string into an API. You actually have an enum, right? So you can then get IntelliSense, and so you can kind of discover this plethora of APIs in a lot more user-friendly way, kind of like you've had for years in .NET. And there's even helper libraries to do things like SQLite. So SQLite's a database that's an embedded database that ships with iOS, and so it also ships inside of Mono for Android. So we have an ADO.NET provider that wraps that, and as well as people have developed third-party object relational mappings on top of it to make it a little more friendly use. But we have that. Right with Mono for MonoTouch. There's the out-of-the-box ADO.NET wrappers over SQLite, so that makes that data access code to local databases a lot more familiar to .NET developers. And then there's some big important point. You can import most non-UI code with little or even sometimes no code change, with the caveat that the OpenTK guys, if you do an OpenGL, you can even get the UI code. Now, along with that, we ship libraries that come with it. So when you get iOS, there's these things called tables, UI table view, UI table view controller, kind of basically lists, as you can see here. So Miguel had written this great library called MonoTouch.Dialog, and what it basically does is takes this very powerful control, UI table view, and then the controller that goes with it, UI table view controller, and it allows you to basically abstract that away in a real declarative fashion, and create the same kind of applications in fraction of the code. So it's really wonderful, and there's a huge amount of documentation up on our site, and we have some videos and things you can explore. But you can see here all these applications, all these screens here were created with MonoTouch.Dialog. Makes creating apps that are table-driven apps, which are most of the non-game apps you'll find on iOS use that. So it's kind of probably the #1 use control, UI table view controller, and very powerful. A little bit involved to work with the code in it, and I'll show you it in an example. But if you did it, once you want to still understand how to use UI table view controller just for understanding purposes, but once you do, I mean, using MonoTouch.Dialog makes that a breeze. So a little bit about how MonoTouch works. I won't go too much because I want to get over the examples here, kind of getting in towards the end of the time. I have a lot of material. So like I said, it uses ahead of time compiling. It produces a single statically compiled ARM binary. So the kind of the secret sauce is the ahead of time compiler. It pre-generates all the native code that JIT would normally generate from IL, right? So then what it does is it leaves you with a single native binary. Basically, it links that together with the JIT-less runtime, right? So you still have the mono runtime, right? And that links that together with a single native binary ARM, right? That you can sign, and all the I/O is stripped away. So you are still left with DLL. So when you build a MonoTouch application for a device, if you unbundle if you unzip the bundle and you looked at everything that was in there, you'd see that that single binary that you can sign and deploy is part of the bundle. And you can look at our docs. It explains how to deploy. It's just basically you package the thing up in a zip file and you deploy it. But in there, you'd also you'd see a bunch of DLLs. But those DLLs don't have any IL in them. They're stripped out. They're only left with metadata, right? So that's how it works underneath. Just a little bit of internals there. So you might be thinking, well, that's great. It's all this ILL, but and we talked about this. It doesn't allow JIT, and that's just what I mentioned just now, that it gets stripped, all the ILL gets stripped out. But not having JIT does have impose a few limitations that wouldn't be imposed in other environments, like say Mono for Android or other places you have .NET. So again, we talked about Apple restricting executing writable memory in the kernel. It's also restricted by policy through their license agreements. So it does eliminate a few areas, other kind of dynamic areas of .NET. So reflection works, but not reflection emit. You can't do code DLR, stuff like that. So there's a few things. So there are some. So if you have code like that, that's the kind of code that wouldn't work in MonoTouch, right? So most things work though. So but if you do have, if you do use any of those things, that stuff would have to be factored out if you wanted to use it in other environments, but in iOS, because iOS, it's a limitation Apple has. Again, that you can't JIT, you can't execute writable memory. So we talked about the GC and retain counting. I don't have to go in this here. It's all abstracted away. That's basically the point of this slide. So you have garbage collection of managed code, and all of this retain counting business is abstracted away for you. You pretty much don't have to be concerned with it. There's one kind of exception. If you spin up your own threads, you have to write this one line of code to create this thing called an auto release pool. It's really pretty straightforward thing. But other than that, for the most part, you're pretty much in a memory managed environment. So classes of problems kind of go away, right? Yeah, that's what I'm saying there. I'll leave that at that. And we tooling. So we integrate with Apple's tools. So again, it builds on the iOS SDK. It builds on top of Apple's tools. Just going to blow through these things here and get to an example, because we're going to see what that's about. So let's skip out of my hello world example here. I'm just going to go right to the second example that has the code views. So I think I can show you both things. This up here. A second to load. So, okay. So again, Mono develop looks just like the one same ID we had. Let me make this a little bigger so you guys see it. So here's a thing I call search demo. Let me run it and I'll show you what this thing does. So this is an iOS simulator that we integrate. So when I launch the application in MonoDevelop, it launches the iOS simulator because I had my build set to debug iPhone simulator. If I plug in a device and I set it to device, I can launch it on a device. If I have a thing called if the device has been provisioned for development, it's a pretty straightforward thing to do. It's pretty well documented up on docs.xamarin.com. So anyways, here I can search for, just like I did in the Apple one. I got a little more into the example in the iOS one here. And I just have a little search bar, and I go search, and I get a list with the results, and I can click in here, and it loads the page, just like in the other example. Here, I want to unplug this for a second. Just want to play this for you here, see if you can hear it.
Xamarin.
So you can see, I'll just play it again.
Xamarin.
Hopefully you heard that okay from my speaker. So that's what I did there. I got a search, and then I added the extra feature there that I took the title out of the search, and I just I basically read the title. I send that string back to the Bing service for a second call, actually the translator service, and I got back audio in a stream that I can then play with a native classes from iOS, just like if I was doing it in Objective-C. So let's go over now and show you what I did here. So there's these things called zip files. So what those are is they're designer files for iOS. And what it does is if I double click on it, and it'll launch Xcode and load up a tool called Interface Builder. And Interface Builder is basically their design tool. And I'm sort of getting near the end of time here, so I'll come back to that if we have a minute. But what it does is it's a design surface that allows you to drag and drop controls on it. And then the one thing that's different about it is it doesn't generate code. Unlike things like the Android one, which generates XML, or things like you may be familiar with Microsoft's technology, Silverlight, or even WinForms, ASP, whatever it may be. You typically, what would you do? You drag, say WinForms, right? You drag a control on, you double click it, you get some event handler and a code behind. There'll be some code generated that actually news up the code underneath in some partial class that's hidden. And then if you set properties, colors, width, whatever, code would be generated for all that. So Interface Builder doesn't do that. It actually serializes all the changes into this file. It's basically it's an object editor. There's no code generated. The only code that's generated is the code that actually connects you from controls and code to the actual design, so basically pointers. But there's no code generated to actually new up the controls. They're actually brought to life just by deserializing this file, right? And basically loading it. And event handlers are just wired up like in code like you normally would, but there's no code generated for things like if you were going to change the color or change the width of things. It's all just done directly into this file and that state gets serialized. So I'll show that if I have a minute in a minute here. If not, we've got a lot on our site. But I wanted to jump ahead so I can show you this example code. So there's this thing called a search item view controller, right? And a search item view controller, it's just a UI view controller. What that is, that's the actual screen, the second screen that I loaded that actually has a web view in it. In this case, there's nothing like intents that load up system things. There's a few things like that actually, I take that back. But in this case, I'm actually creating the second screen in my application through this thing called the search item view controller. iOS development uses a model view controller pattern throughout. So you have controllers and you have a model and then you have some view, right? And you have a hierarchy of views. So every controller has a view. In this case, I subclass UI view controller, and I added that web view in Interface Builder, which I'm going to skip ahead on and show you, go back to and show you. So that web view is coming to life from Interface Builder, where I just dragged it in the designer. And then at that point, I connected it, and I'll come back to that and show you. And then I just load up the web view with the URL from the first screen. So I'm working in reverse here, right? Let me go back over here now, and I'll show you the search results controller. So that was the second screen, kind of the detail screen. If I do it over here again, Apple this time. So that's the search. Oh, killed it down with it. So that was the second screen with the browser was the search item view controller. So now this first screen here comes from the UI table view controller that I've created called search results controller. And that's like the thing that you can abstract away with MonoTouch.Dialog and how I probably do it. I just wanted to show it for demonstration that you can have a UI table view controller directly. That's just like you would do with Apple. And then a UI table view controller has a UI table view. And a UI table view controller in this case, I keep a model, which is the search results of search item. Search item is the class, the exact same search item class we had, feed title and URL, simple, but that we had from the Android side, right? So here I use that and I just create a list of them, right? So I have generics, I have a list of search items. So that's, the model's reusable. The controller's not, that's specific to the platform. View's not, that's specific to the platform, right? But then then there's a bunch of code in here that basically does the search, puts the search bar on, and then just gets the results back. There's a thing called the delegate in iOS. It's basically a callback class, and not like a .NET delegate. It's more like an interface, but it binds a thing called protocols, which are like interfaces have optional methods. But anyways, it's basically a callback class, right? So when I do the search, I get a callback, I get results. I take those results, and through a callback class, the UI table view says, hey, where do how many rows do I need? I get the number of rows I need based on the number of results I have, and then I just build up cells and I create all the cells to put the results in, right? And then when the user taps on it, I handle that, and then that navigates them over by pushing onto this thing called the UI navigation controller, which manages a view controller stack to the second screen, and that's how I would get to the second screen. Great, so that's all native. There's a bunch of native stuff basically to put a table on the screen, use the search bar, calls out to Bing. And then when I get the results back, you tap, it goes to a second screen. Again, native stuff. I can design completely in code, like I did here with the UI table view controller, or I could use the designer that I haven't shown you. I'm going to come back in a second and show it to you just for completeness. But I do want to show you this class called Bing. So this class here, let's just make it a little bigger. So remember in the Android example, I changed the names here from R and J minimal, the response and JSON. But this is the same code, right? So there's the exact same code, this code here, that we had in the Android example, right? Used here. The only thing changed is I just changed the variable names for some, just to make them a little more clear what was going on that I had in the Android example. But exact same code, and I can put this in a class like this, Bing helper class, and then have it be completely reusable. And what happens is, if you recall in the Android example, I had some code that put it in the list via this thing called the list activity. Here I actually factored it away through a .NET delegate. And then I just invoked that delegate here. That's what sync is. And by doing that, I can pass in the implementation for that delegate from the caller, which is the controller, the caller of this Bing class, the thing that actually the user, the list of search results and the search bar with the little, where I entered in Xamarin and hit search. That is where I actually implement that callback, and I just pass the delegate in here, and just by having a little delegation pattern, or if you had multiple things you wanted to abstract away, you could do it through an interface. I'm able to keep this class iOS free for the most part, right? Keep it pure .NET. And that's a pattern, the kind of patterns you could use to allow you to have code reuse. Just to show you down here, also I didn't run it, but there's also a link to XML support, and the exact same example done with a link to XML. Again, there's your Bing web service that allows you to do XML. And if you want to, even though you won't get the code reuse if you do this, non-iOS classes, obviously iOS, Apple has non-UI classes, right? Obviously to do HTTP, do things that have nothing to do with UI, they're just iOS only. That's all available as well. So stuff in what's called Core Foundation is available. In this case, NSURL request. So if you want to use those kind of things, maybe you're porting some Objective-C code, that kind of scenario, you're completely able to use that as well. Just of course that, even though it's in C#, that kind of class wouldn't be reusable because it's iOS specific. So let's just jump one thing here. I just want to show it to you. So it kind of ran a little long on time here. If I double click on this zip file, I just want to show you here if I can get it. This is the Xcode, and this is the interface builder tool that's built into Xcode. And these are the controls I dragged and dropped on, and then I connect a thing called an outlet. Check out our doc site, which I'll show you now, for more information on how to use the interface builder tool. So that's how I got that second UI with the web view in place. So let's back to slides, and we'll close up here. So let's talk a little bit about cross-platform. We talked about how you can factor out your core code, your code that's non-UI code, classic kind of architecture that you probably do anyway. Have the UI abstracted away, but build a native UI, have a native experience, have it not look out of place, have real good performance, and have all code reused down at your kind of core level, which I even did for that simple example where I had the Bing class there. Right? Now, if you want to see a more complex example of how to do this, we created an application for the Mobile World Congress conference that took place in Barcelona just earlier in the year, and it takes advantage of a variety of different technologies. MonoTouch.Dialog on the iOS one, how to factor code away, and we built it for Android using Mono for Android, iOS using MonoTouch, and we even built a Windows Phone version, and we shared all the non-UI code into core libraries. So that's all available up on our in our sample site, and you can get to it straight through the MonoTouch documentation or directly through GitHub, and there's the link there. So everything's available through our doc site, and you can link through samples there. But if you give you a second to look that down, it's in github.com/Xamarin, and you go through that, you'll find all of our samples are up there. And you can see there's some screenshots both on the iPad, the first one. The second one is iOS. Then we have the Android version, and you can finally see the Windows Phone 7 version as well. So that's a really good example if you want to see a more intricate example of both how to architect an app like that, even without code reuse, just to have it architected very well for making it testable, as well as how to, at the same time get quite a bit of code reuse out of your non-UI code. Right? So last thing I want to mention here is, so I talked about reusing, you could reuse non-UI code, you build this native UI, but I mentioned briefly earlier, there are these classes that aren't UI, things like location. Some of them are UI, like you get native support for context, but the concept is sort of abstract or universal. Every Android has context as well. Windows Phone has context. Obviously, accelerometer, compass, those things have no UI. They're sensors. Then there's notifications, and they all have cameras, but they maybe present some different UI. So in places where it made sense, where there is some native support for something that's either a stock UI on a particular platform, right, that users wouldn't create their own, but are abstracted to an API, or have no UI, like stuff that could, like an accelerometer, where it's just a sensor. We've created, or we're creating, this library called Xamarin.mobile, and that's a helper library that sits on top of these things to give you that out of the box. So it's in pre-release right now, but it's going to be, it'll be maturing and coming out, and so you can download it off our site. And it's the idea of that is to, in addition to give you a bit even more of a code reuse story, right? And have some things to not have people have to reinvent these things every time, and be able to just write one set of camera code. The other side of it is some of these APIs on the particular platforms are a little bit verbose. For example, the address book API on iOS is quite laborious to work with. So we simplify that a bunch, and then we supply really great link support for it. So it makes not only do you get the code reuse part of it, but you get in some cases a nicer factored library and API to work with. So last thing I want to then show you here, that was the last technical thing I want to talk about. I just want to mention our doc site. I'd show you. So we have at docs.xamarin.com and /iOS and Android for the Android one is where we have a variety of getting started tutorials as well as more advanced tutorials on a bunch of different topics. The place to get started with both iOS and Android is in each topic. I'll then jump ahead to the Android one, docs.xamarin.com/Android. And if you just go to docs.xamarin.com, there's a couple buttons that will take you into either one. There's a getting started series for each product, and you should probably that's the place to start to walk through. It'll walk through, taking your time walking through from getting installed to, going through a simple screen app to a multi-screen app like that. When I showed you something like that and explain a little bit more conceptually, and then give you some pointers to like where to go next into some more advanced tutorials, and then there's tutorials on the designer, there's talk about iOS architecture and then how our products work, and then some. So and we keep adding to that. As well, there's these, you see up on the top, there's these recipes. So in addition to all the document, the longer conceptual articles we have on both products, we have these things called recipes, which are more like cookbook style examples. So it's just little examples with a little walkthrough. And we have over 100. We have a lot of them right now. I think 120 or so recipes, something like that. And they're available for MonoTouch and for Mono for Android. And yeah, and there's API reference, of course, is up there. And the samples will get you to that MWC sample I mentioned, as well as all our other samples, which you get a little page where you can see what the sample's about, and then there's a place where you could click over to go to where it's hosted on GitHub. And all that's open source with a nice license to allow you to reuse it commercially as you need. So thank you. I ran a little bit long, so apologies for having to rush a little bit at the end. So I think we got a bunch of questions. We still have some people hanging around, so I'm going to try to ask a question. I'm going to try to spend a couple minutes to answer the first couple of these best I can. If I don't answer your question, feel free to use that. Let me go back to get you my email. If folks hung on long enough, you deserve an answer. So just not keep you too long tonight. There's my email here, mike.lucine@xamarin.com. Feel free to, if I don't answer your question or you feel like you have anything at all, more information you need, feel free to use that. And I answer everything. So shoot me an email if you have another question or you think of something afterwards. Happy to answer it, or if I can't, to get someone else to pass it along to someone who could. Right. So let's see this first question. How do we integrate some native Android code in an app? So yeah, that's like, so native Android code meaning, so obviously the stuff I mentioned, to use Android code from the Android SDK, there is no integration. You just use the classes that are available through mono.android.dll. Now, if you wanted, if you're probably asking about there is if you wanted to integrate, say, some third-party library, right, or some Java code you wrote yourself, whatever it may be, you can use our. That's where there's different ways to do it. So one way is you could port it, right? You could try to do a line-by-line port if you wanted to get it all in C#. Depending on the scenario, that may be a good way to do it or not. If it's well tested or a real big code base and no reason to try to touch it, you just want to use it and call it as an API level, you could use the bindings like we have. And then there's another thing. There's some, you can use our binding project, and then there's some more details in there to use these various attributes we have that allow you to create to bind manually. And then that said, you can also go down the road. I didn't talk about JNI today. There's a very big comprehensive document on JNI, which is a little bit harder, more involved way to do it, but you can use JNI as well. But the way to go is to, unless you run into a problem, and if you do, by all means let me know or contact our support up on our site, but is to go through the binding project. So let's try to jump down to the next question. Does the debugger encapsulate the debugging features available in Android development for Eclipse? Well, it's its own debugger. So we have a debugger in Mono for Android inside of MonoDevelop and inside of Visual Studio, and it has the kind of it has watch windows. It has stepping and jumping over, and you can pin. You can do some things. I've actually used the Eclipse one without giving you too deep a quick answer. It's got some features that you'll find, especially if you've never used Xcode, we kind of blends kind of usability features from different places. So you'll see things that look familiar from Visual Studio, like pinning. You'll see some other things, even in just the IDE in general, like the way the error bubbles kind of show up, and then there's watch windows. So it's not the debugger from Eclipse, but it's a quite nice debugger, and it's yeah. So I'll just leave it at that. So it's a different debugger, but it's pretty full featured. Works on the device as well, so you get device debugging as well as on the I almost said simulator, emulator on Android. So almost got through it. Let's try to get through them all. So can we import a Mono library from a Mono Android project and drop it into the MonoTouch solution? You have to go through source code, right? So you don't right, you wouldn't move DLLs around, right? And the limitation there is because again you have to go through source code, right? They are different, so there's source compatibility. There's that I won't go in it, but if you're familiar with the portable library project, I'm gonna lose my place from Microsoft, where there's some support for that. There's been talk about it. I shouldn't probably say it since I don't know definitively, but I saw some talk about it today. So maybe if you want to shoot me an email about that, that might be something that could be useful to you. Yeah. So, or I could point you to a reference on that. Maybe I shouldn't have brought it up since I know the answer, but that's something that I think is coming if it isn't there already. So last thing is, can I write my code in Objective-C using Xcode and import it in MonoTouch? So you can write your code in Objective-C, and you could use bindings just like we bind MonoTouch. And I've done this many times myself. So you could take an existing library that someone else wrote, some open source thing, right? And we have bindings for a lot of open source products, Red Laser, you name it, there's a bunch of things. And you can make a library and you could write your application that way and expose it through a binding. Now, if you wanted to go and you wanted to say, create your app in Objective-C, use Xcode, and then say, like in that Bing example I had, just write the reusable part in C#, there's no nice way to do it. There's a way to do it, but it's quite a bit of work. It's not really supported. Maybe some point that might change, but most of our users come from the .NET side of things. But certainly you could write code in Objective-C and you can bind it and you get the exact same tool chain to bind it. I didn't go into detail here. It's called btouch. There's see the article on the doc site about how to do bindings in the iOS portion of it. There's a detailed document about how bindings work and how you can manually create them. But then that said, there's a nice tool chain, and there's a tool called btouch you could use that allows you to then create bindings. You basically create a contract through an interface, and then you decorate it and with some attributes, and then you run this tool and it creates the binding for you. So, and then you can shape the binding to make it more .NET-like, just like we do with MonoTouch. Expose things like enums and attributes. You can make it as .NET friendly or .NET-like as you want. But yeah, so you can totally bind Objective-C though, and you can p-invoke's available too, so you can p-invoke to if you just go in it's C code. So that's all the questions that looks like we have here. So good, we got everything. If anyone again has anything, we've run 12 minutes long. The folks that have hung on, I really appreciate you. Hope this has been worthwhile to you. If you have anything else again, by all means, shoot me an email. Anything you want, I'll try to get you an answer. Or if you think of something afterwards that you didn't ask here, you wanted to ask, feel free. I'm happy to help. And I appreciate the time you took out tonight. So have a good night, everybody.